In this video, I'd like to take you through two examples of graphing rational functions. Again, this is an introduction to rational functions, so these are some of the more basic types you might see. Let's start with this first example. The first thing that we want to make sure we do is factor the numerator and the denominator. It's our lucky day. The numerator is already linear, and I don't see a GCF, I don't see a greatest common factor, so there's nothing we can do with the numerator. The denominator, though, it looks like I can factor that into x minus 2, x minus 1. Now that I have that factored, I can check for discontinuities. That's one of the first things I want to check for before I make my graph. And I can easily see the discontinuities in factored form. I notice that there is a factor that cancels out x minus 2, so that told me that there was a hole in our graph. The x-coordinate of the hole is coming from the factor that canceled. The x-coordinate is 2. How do I figure out what the y-coordinate is? I always like to rewrite my simplified function after I've canceled out that common factor. And it turns out in this case we get 1 over x minus 1. That is the function that I would like to use for the whole rest of the problem. I've already removed our discontinuity. So now I can find the y-coordinate of where the hole in our graph is by using our canceled function. If I plug in 2 to our canceled function, I get 1 over 2 minus 1, which is 1 over 1, which is 1. Notice there's another discontinuity. X minus 1 did not cancel with any other factor. That means that we have a vertical asymptote at x equals 1. It's really handy that I list those things out. It's going to be very helpful for when I graph. The last thing I want to think about is the EBA, the end behavior asymptote. I can think about this in one of two ways. First of all, I see the degree of the denominator is larger than the degree of the numerator. So I know right away our EBA is going to be y equals 0. Another way of investigating this is by looking at our canceled function, what we ended up getting when we canceled that factor. That's 1 over x minus 1. Now, I've graphed the function y equals 1 over x before plenty of times, so I know what that looks like. This function is just 1 over x shifted to the right 1 unit. So I could also think of it just as a shifted inverse variation function. Let's sketch our graph. First, I'm going to dot in the two asymptotes that I know exist, x equals 1 and y equals 0. Now, I know there's a hole at 2, 1. So I'm going to sketch in an open circle. Now, how do I get other points on this graph? Well, I know that this is a shifted inverse variation function, so I know my favorite points, 1, 1, and -1, -1, on our graph of 1 over x, have just shifted 1 unit to the right. So I know that this point is on there, and I know that this branch of our function heads downwards and to the left in that fashion. It's kind of hugging the asymptotes. On the other side, the point that would have been on the ordered pair 2, 1, that turned out that was where the hole was. So I can sketch the rest of the function in, but I can't actually plot a point at 2, 1. That was the hole. So our function really is a shifted inverse variation function. It was 1 over x shifted 1 unit to the right with a hole in it, with a hole at 2, 1. That's it. There's the picture. Let's try another example. It's our lucky day this time because it's already in factored form. I don't have to factor the numerator. It's already done for us. Do you see any discontinuities? I see the factor x minus 1 that canceled out. So I know that there is a hole in our graph at 1, Let me rewrite our canceled function. Once we simplified it, we just get x plus 3. So when I plug in the x-coordinate to our function, I get 1 plus 3, which is 4. We have a hole at 1, 4. Let me think about what this function looks like. I don't see anything else in the denominator. There's no more variables in the denominator. Our denominator is now just 1. So there's no other discontinuities. There is no vertical asymptote here. In fact, you already know what the graph of y equals x plus 3 looks like. That's just a line with slope 1 and y-intercept 3. I can actually plot those points. If our slope is 1, let's see, I know that we have just a line. But don't forget, there is a hole at 1, 4. So instead of putting the point there, I'm going to plot a hole, an open circle. Don't forget about previous knowledge. You know everything in the world about lines. You know how to find their slope, you know how to find the y-intercept, you know how to graph them, you know how to find points on them. The only difference, the reason that this line was a little bit scarier than lines that you graphed in Algebra 1 was because this line had a hole in it. So the original equation looked kind of scary, but it turns out once we simplified, it was just y equals x plus 3. That's not so scary. We just had to remember to sketch in the hole at 1, 4. That's it. I think we're done with our 2 examples. These are some basics of graphing rational functions. Good luck with the rest of them.